Welcome to a short presentation on using variables and assemblies in Sage 100 Contractor Basic Estimating. Concept is pretty simple. When we create assemblies, by default they are connected so that we can multiply the takeoff quantity times the recipe quantity in the assembly. These can be disconnected with a few double clicks. We can use the disconnected parts to store the values in the quantity column in a variable. And then we can use those variables to calculate quantities or prices on the real parts down below. The advantages of this are pretty significant in that we have a short interview process to make sure that the entire specification is addressed at the time we do the takeoff. We have fewer assemblies in the database, and we have faster, more accurate estimates. Let's demonstrate. What I'm going to do is I'm going to bring in an assembly. Bear with me just a second. This is a 3x3 window frame only. This will be used by a framing contractor. It's got all the necessary parts and labor to frame this in an exterior wall. Notice that we have a standard 0.4 hours of skilled labor and a standard 0.6 hours of unskilled labor to do this job in normal circumstances. Let's say we've got a nice fast crew in here and we want to adjust down on that. And what happens then when we hit the calc button is the quantity goes down for the labor, and so the cost goes down. We take that and multiply it, let's say, by 75 feet, or excuse me, not 75 feet, we got 3 each of these. Do a quick calc. And this gives us a unit cost of $45. These prices may not be too current. $45 to frame the window using a 90% productivity factor. Let's assume that it's a harder job and we're going to raise that productivity to 120%, and we've taken it up almost $5. Again, pretty simple and straightforward. What we've done is you can disconnect any part with a couple of double clicks. Double click and we can put it back. So that's a pretty simple example, just using productivity as a variable. We're going to go out here and make this a little more complex. We go down to the bottom of our list of assemblies in here, and I've got a 24 gauge rectangular duct that might be used by a sheet metal contractor to fabricate and insulate and install that section of ducting. Let's assume that we've got a 35-foot section and that we're doing 24 by 24 inch duct. So notice we're taking the 24 and we're storing it in a variable called HT for height, and we do this with this little technique where HT equals Q. Do the same thing for the width. And then we have other variables in here. Is it insulated? What's our standard fabrication rate per lineal per lineal foot? And we can do about 6 feet an hour. We can install about 50 feet an hour. We can insulate about 10 feet an hour. We have waste for both sheet metal and installation at about 15% as a standard. Standard 6-foot drop, we're going to change that to 5 for our little project here. Standard spacing is 4 feet for strapping. We'll assume that that's the same here. These represent some intermediate calculations. Let's not worry about those for right now. And as you can see, we're going to take those variables and then the subsequent intermediate variables that we have created down here in this fairly complex set of formulas. And we're going to use those to calculate how many sheets we need for a per lineal foot. In this case, 0.2, what the fabrication is for the labor, the duct install labor, et cetera, et cetera. So again, we simply ask the questions, press the calculate button, and based on these, we're going to do $39 a lineal foot for everything, including sheet metal, insulation, labor, etc. When I get done doing the takeoff for that section, maybe I've got another section. I'll use the same assembly, 3474, and take this down to 20 inches, 20-inch duct. We're going to use the same rates per hour. We do have a different drop of 5. And again, calculate, move on. 3474 again. And now we've got 18 inches, 18-inch square duct in this case. We've got 18 feet of that. And again, our 5-foot drop. And a quick calculate and set to go. That's basically how this works. There's a little more to it in the way we put these things together. The first one of these can take a little bit of time because it has to be tested to make sure that it works. But to create new guys or new assemblies from old assemblies is pretty simple. I simply start with something that is pretty similar to what I'm about to do. And what I'm going to do now is I'm going to change this to, I believe I've got 18 gauge in here. So I'll just copy that with this copy button, start a new assembly, and paste. I'll change this to 18 gauge. And I'll assume that all of my quantities are the same. That may not be the case, but for purposes of our example, we're going to say that it is. And we now have a brand new 18 gauge assembly in just a couple of seconds here. Save that. And we can now use that in our takeoff. Calculate and go. If you have any questions on any of this, please give us a call. We are CFO on the Go. This is our contact information down below. My name is Jim Cumming. Thanks for watching. Have a great day.